Visit Chandra's beautiful universe. Able 98. Astronomers taking inventory of the material in the local universe keep coming up short. A new result from NASA's Chandra X-ray Observatory about a system of colliding galaxy clusters may help explain this shortfall. Although scientists know a great deal about the composition of the universe, there has been a vexing problem they have struggled to explain. There is a significant amount of matter that has not yet been accounted for. This missing mass is not the invisible dark matter, which makes up a majority of the matter in the universe. This is a separate puzzle, where about a third of the normal matter that was created in the first billion years or so after the Big Bang has yet to be detected by observations of the local universe. That is, in regions less than a few billion light years from Earth. This matter is made up of hydrogen, helium, and other elements. It makes up objects like stars, planets, and humans. Scientists have proposed that at least some of this missing mass could be hidden in gigantic strands or filaments of gas in the space in between galaxies and clusters of galaxies, with temperatures between 10,000 and 10 million degrees. They have dubbed this the warm-hot intergalactic medium, or WHIM. A team of astronomers using Chandra to observe a system of colliding galaxy clusters has likely found evidence of this WHIM residing in the space between them. The researchers used Chandra to study Able 98, which contains colliding galaxy clusters about 1.4 billion light-years from Earth. The Chandra data reveal a bridge of X-ray emission between two of the colliding clusters, containing gas at a temperature of about 20 million degrees and cooler gas with a temperature of about 10 million degrees. The hotter gas in the bridge is likely from gas in the two clusters overlapping with each other. The temperature and density of the cooler gas agree with predictions for the hottest and densest gas in the WHIM. Only a few detections of the WHIM have previously been made. In addition, the Chandra data show the presence of a shock wave, which is similar to a sonic boom from a supersonic plane. This shock wave is driven by and located ahead of one of the galaxy clusters, as it is starting to collide with another cluster. This would be the first time that astronomers have found such a shock wave in the early stages of a galaxy cluster collision, before the centers of the clusters pass by one another. Galaxy clusters, which contain thousands of galaxies, huge amounts of hot gas, and enormous reservoirs of dark matter, are the largest structures in the universe held together by gravity. Scientists think they are able to reach their colossal size by merging with one another over millions or billions of years. When galaxy clusters collide, astronomers get a chance to see extreme physics that they rarely see in any other cosmic setting.